Welcome to the deep dive. We're here to unpack some fascinating science and, well, really get you the core insights.
That's the plan.
So today, we're tackling a word you definitely hear a lot, often with a bit of worry attached: cholesterol.
Right. Cholesterol, it pops up everywhere in health conversation.
Exactly. But what is it, really? Beyond just a number on a test, and maybe even more interesting, how does our body, specifically the liver, manage it all? It's quite the performance.
It really is. I mean, it's fundamental. You need it for cell membranes, hormones,
No.
so many things. But yeah, how the body handles it, that's a whole different level of complexity. It's like this intricate biological dance.
A dance is a great way to put it. And that dance, especially the liver's leading role and how something common like statins interacts with it, that's our focus for this deep dive. We've pulled the key ideas from a really clear explanation over on the YouTube channel, Metabolism Made Easy.
Yeah, they do a good job breaking it down.
Our goal here is pretty simple. Give you a really clear understanding of the liver's job in managing cholesterol and exactly how statins tap into that natural system to lower cholesterol in your blood. You know, the LDL kind people often call bad.
Right.
By the end, you should have a solid grasp of who the main players are and how they, well, interact in perhaps surprising ways.
And it is surprising for many people. Like, did you know your liver isn't just, say, filtering things. It's actually a major cholesterol factory, and it's also the main recycling plant.
That's such a key point because it kind of flips what most people think, doesn't it?
Totally.
We tend to focus so much on, cholesterol in food, but you're saying the liver itself is the chief manufacturer, making most of it.
That's right. The majority is actually made right inside your body, primarily in the liver. So it's making it and recycling it.
Okay, so if it's doing both producing and pulling it back, what are the two big ways it controls the levels floating around in our plasma, the liquid part of our blood?
Okay, yeah, two main things to grasp. First, like we said, the liver is the #1 place cholesterol gets made.
Yeah.
Biosynthesize is the technical term.
Right.
It builds it from smaller pieces.
Yeah.
Right inside its own cells. Think of it like a dedicated production line.
Got it. So it's not all about diet. A lot is homegrown right there in the liver. Okay, what's the second big lever it pulls?
The second crucial thing it does is remove cholesterol from the bloodstream.
Ah, the recycling part.
Exactly. It grabs these things called LDL particles, low-density lipoproteins. They're basically the transport trucks for cholesterol in your blood.
Okay.
And the liver has these special docking stations on its cell surfaces, LDL receptors, that snatch these LDL particles and pull them inside the liver cell.
So producer and cleanup crew, pulling it back out of circulation, it sounds super efficient, like it should regulate itself perfectly.
Ideally, yes. It's designed to be a balanced system.
But obviously, sometimes that balance goes off track. And that's where medications like statins come into the picture. How do they actually step in and sort of nudge this system?
Right. And this is where it gets really interesting from a medical standpoint. With statins, the main action is inside the liver cells. They deliberately slow down cholesterol production within those cells.
Oh.
They work by blocking a really specific enzyme. Think of it like a key switch in the production pathway. Statins turn that switch off, or at least way down, inside the liver cell.
Okay, so statins basically hit pause on the liver's internal cholesterol factory. Makes sense.
Yeah.
But what happens next when the liver cell realizes, hey, my internal cholesterol supply is dropping? Does it react?
It absolutely does. That slowdown causes the cholesterol level inside the liver cell to decrease. And that drop right there within the cell is the crucial signal. It triggers the next step.
Which is?
The liver cell responds by making more of those LDL receptors we talked about, the docking stations, almost like the cell's thinking, okay, we're low internally. Let's grab more from outside.
Okay, that is clever. So it makes more receptors. Do they just hang out inside the cell?
Nope. They get moved, translocated right to the surface of the liver cell. So now you've got way more of these LDL receptors sitting on the outside of the liver cells ready to grab LDL.
More grabbers on the surface?
Exactly. And with more of these receptors available, the liver becomes much, much better at pulling those LDL particles directly out of your bloodstream.
And that's the goal. When the liver pulls more LDL out of the blood, your overall plasma cholesterol level goes down.
Precisely.
It's like strategically nudging your own body to beef up its natural cleanup system. That seems like the real insight here.
It really is a fantastic example of how understanding the body's own internal checks and balances, like the liver sensing low internal cholesterol and making more receptors, lets us develop very targeted treatments.
Yeah.
You're not just, masking something. You're leveraging a natural feedback loop.
Okay, so let's just quickly recap this deep dive then. Your liver, it's the main place cholesterol gets made, but it's also the main place it gets removed from your blood.
Correct on both counts.
Statins work by slowing down the cholesterol making inside the liver cells.
That internal slowdown,
And that simple action cleverly triggers the liver to make more LDL receptors.
which then appear on the cell surface.
And those extra receptors act like hooks, basically, pulling more of that LDL cholesterol right out of your blood plasma.
Exactly. It's quite an elegant mechanism when you break it down.
It really shows how interconnected everything is, doesn't it? How adaptable these systems are. One little change triggers a cascade.
Absolutely. It's all about maintaining balance, homeostasis. The body is constantly adjusting.
It really does make you stop and think,
Yeah.
about all the incredible, intricate stuff happening inside us literally all the time, totally automatically.
Below the level of consciousness.
Yeah. So maybe something for you to think about. What other everyday biological processes are running on these kinds of complex, self-correcting feedback loops? Things we don't even notice, just subtly keeping everything running smoothly.
It's a good question. It highlights just how responsive and, frankly, beautifully designed our internal chemistry really is.
A fascinating thought to end on. Thanks for joining us on the Deep Dive.